Hello, welcome to Unit 3 test review here. We're going to do test review day 1. Our goals today are to review the equivalent expressions. So we're going to go over what it means for expressions to be equivalent again. And then we're going to review multiplying polynomials, and we're going to review factoring. All right. If you're looking for a specific problem here, if you're not wanting to watch the whole video, I completely understand that. You're going to want to fast forward until you see the problem it is that you are looking for. All right, so here we go. We're going to talk about determining whether or not two expressions are equivalent or not. So our two expressions here, we've got f of x and g of x. We've got x squared minus 4x plus 3. And then over here, we've got x plus 1 times x plus 3. So the question is, are these equivalent? And if you're familiar with factoring, you're probably wondering, well, this looks like it might be the factored form of this, but it's kind of hard to tell. Right, so we're going to start collecting evidence to make a decision, right? So right off the bat, you might guess, yes or no, maybe they're equivalent, maybe they're not. But whatever you decide, right, you have to have evidence to back it up. All right, so the evidence that we start collecting, I like to start with the tables. So I've got two tables drawn up, and this is what you're going to see on MyOpenMath when you do a problem like this, right? You're going to have a table set up for each function, and we're going to test the input values 0 through 5 on each of the functions, and we're going to take a look at what the output values are for each function. All right, so to do that, I'm going to go over here to my calculator. I'm going to turn it on. There we go. And I'm going to hit y equals, and I'm going to enter in each of my functions. So in y1, I'll put f of x, and then in y2, I'm going to put g of x, right? So you just type those in. You can type them in both at the same time, probably save you a little bit of time. Then we're going to go right to the table. So if you hit second and then graph, you'll get a table, and you'll notice over here, these are the inputs, right? Remember, the inputs are going to be the same, right, for each of the functions. So 0, 1, 2, 3, 4, 5 are the ones that we're looking at, and then the blue numbers over here represent the outputs for f of x, and the red numbers over here represent the outputs for g of x. All right, so let's start with f of x here. So when I put a 0 in, I get a 3 out, right? So I would go 0, and then 3 would be our first output value there. And then you can go right down the list. Okay, so we've got 0, -1, and then we've got 0, 3, and 8. All right, just kind of going down the list there. Now, if these functions are equivalent, we should get the same exact outputs for g of x. Let's see what happens. We're going to go over here, and we've got 3. So far, so good, right? 0, 3, and we got 0, 3 over here too. So when we go to 1, right, we're going over to the red column now. We've got an 8. Okay, and that's not good news, right? Because when we put a 1 into f of x, we got a 0. When we put a 1 into g of x, we got an 8. So I can tell you right now, these are not equivalent functions. Right, but I'm going to go ahead and fill in my table, and you can see as I fill this in from my table over here in the calculator that these are not the same, right? So what do you notice about the tables? They are different. Right, they are different tables, they have different inputs and outputs, and does it suggest that they are equivalent expressions? The answer to that one is no. They do not suggest that they are equivalent expressions. All right, so the next piece of evidence that we would want to look at is the graph. All right, and we've got a couple of graphs set up here. This is very similar to how they would be set up on MyOpenMath. So we want to take a look at the graphs. If they are the same functions, guys, you'll see the same exact parabola on each graph here. Now, when we do this on our calculator, if they are the same, it's kind of hard to see sometimes because what you'll get is one parabola that lays right down on top of the other parabola. But if they are different, you'll be able to see the two parabolas distinctly on the graph. So I'm just going to hit the graph button, and let's see what we're getting here. So the first one, that's the blue one, that comes down, that's f of x. And then we should see a red parabola. There it is. Red parabola there, that's g of x. And you can see those are two different parabolas. They are not the same parabola. If they were the same, you would have one lay down right on top of the other, and that's not what's happening here. So I can see from that graph they are not the same. Now on MyOpenMath, they actually want you to plot the parabolas on the two graphs that they give you. And to do that, all you need to do is grab the values from your table that you have up here and plot those on the graph down here. All right, so we've got our first point, and I'll zoom out a little bit so I can get it all on one screen here so we don't have to keep scrolling up and down. Okay, so we got this first point right here, 0, 3. So I'm going to go down here, we got 0, 3, so I'm going to plot that point. This is exactly what I would do on my open math, right? And then we got 1, 0. And so 1, 0, so it'd be right here. And then we've got 2, negative 1. So 2, negative 1. Right here. And then we got 3, 0. Okay. We got 3, 0, and then 4, 3. Oh, these are going up by 3s. So we gotta adjust that. Alright, so 2, negative 1 would actually be like right here. Not quite all the way down to B. Yeah, right there. And then we'd be back up at 3, 0. And then we'd be at 4, 3. There you go. You start to see the parabola take shape there. And then we'd go to 5. And then up to 8, which is just a little bit before the 9 there. Okay. And then you see your parabola. And you're only going to get a chunk of it, and that's okay. You're not going to get the whole thing. I don't want you to graph every single point. Just enough to show that they are different, right? Then we're going to come over here. We're going to graph this one on this graph. So we've got 0, 3 again. And then we've got 3 and 8. It's kind of weird. So 3, 8 would be right here. And then we've got 2. Geez, that should have been a 1, 8. I am messing up. It's a 1, 8. And then we got 2, 15. There we go. 3, 24. 4, 35. And then 5, 48. So way up here. There we go. And you can kind of see this is going to be the right half of the parabola for this one. So this one's coming up like this. And if I can see that piece of the parabola, and we can see like those are not the same. It does not suggest that the expressions are the same. All right. Let's keep going. The last piece of evidence that we would want to confirm whether or not the expressions are equivalent is to show that one function can be manipulated to be the other using mathematical operations. So whether or not you're going to multiply the expressions or factor. So you really do have choices here. You could choose to take this and factor it, and if and when you factor it, it looks to be just like g of x, then you know that they are the same. The other option is to take g of x and multiply it out, and if you multiply it out, you should get what you see in f of x. For most students, multiplying out is easier than factoring, so I'm going to show multiplying out using g of x. All right, so we're multiplying x plus 1 and x plus 3 here, so we're multiplying these two things. So when I set up my box, I'm going to set up my generic rectangle. And I'm going to make it 2 by 2, and the reason being is because when I look at the two things being multiplied, I notice that there are two terms inside of each one. So there's the x and the 1, right? So I'm going to put the x here and the 1 here. All right, and then for this one, there's also two things. There's an x and a 3, so I'm going to put the x here and the 3 here. All right, so that's why I needed a 2 by 2 box to multiply those two things out. Then we go through and we multiply to find the areas of each of the 4 smaller boxes inside. So to find the area of this one, we would do x times x, which gets me x squared. Then to find the area of this box, we would do 3 times x, which gets me 3x. Here we would do x times 1, so that would just be x. And then 3 times 1 is 3. Then we add up the 4 boxes, right? So we would say x squared plus 3x plus x plus 3. And then make sure you combine any like terms, right? So for instance, 3x and x could be combined, so we would get x squared plus 4x plus 3. And then this final expression that you get, you want to compare it to f of x, and we can see the big difference here, and I'll highlight it for you. The reason that they were not equivalent is because this ended up being a positive, and f of x had a negative there in front of the 4x. So they were adding 4x here, subtracting 4x here, and that makes a big difference in the table and the graph as you saw before. Okay, so that definitively shows that they are not the same expressions. Okay, so let's continue on. So again, just talking about equivalent expressions as we continue on through the notes here, we want to be able to write equivalent expressions, not necessarily show that two expressions are equivalent, but just be able to write different equivalent expressions should we need them. Okay, so I want to take this expression that they give me here, I want to write it in a different way, and one of the ways that I can do that is by multiplying these two things, right? So it specifically says to use multiplication. So if it says specifically to use multiplication, make sure you do that, otherwise you could be marked wrong on the test. All right, so the two things we're multiplying, we have this parenthesis here being multiplied by this parenthesis here. There are two things inside of this parenthesis, right? There's a negative 3x and a 2, right? So I'm just going to put a 2 here. And then here I've got 1, 2, 3 terms, 4x squared, 4x, and negative 1. So there are three things inside of this parenthesis. So when I go to set up my rectangle to help me with my multiplication, I'm going to need a 2 by 3 rectangle. Okay, so here we go. Notice I'm making it a little bit longer. That's just to add that third column, right? I'm going to split it two ways this way, right? So I can put my negative 3x here and my 2 here, right? So I need 2 slots here on this side. And then to get this one to go across the top, I need 3 slots, right? So I'm going to make sure that I have 3 slots across the top. So I'm going to have negative 4x squared, 4x, right? So negative 4x squared, 4x, and then negative 1. So now my generic rectangle is set up, and just like I did in the previous problem, I'm going to go through and I'm going to multiply to find the areas of my 6 boxes here. So when I do negative 4x squared times negative 3x, I do that by doing the numbers first. I'm going to do negative 4 times negative 3, that's a positive 12. Okay, negative times a negative is a positive. Then we do x squared times x, right? So remember your exponent rules. If you're multiplying two things with the same base, you add the exponents. When you don't see an exponent, you get to assume that it's 1, so 1 plus 2 gives me 3. Okay, so same thing here, I can assume this is an exponent of 1, and when I multiply these, I do 4 times negative 3, so that'll be a negative 12, and then x times x, right? 1 plus 1 gives me 2, so this will be x squared. And here we got negative 1 times negative 3, it's a positive 3. This one has an x, this one doesn't, so we'll just say 3x. Okay, and we continue for the second row here. 2 times negative 4 is a negative 8. And then we have an x squared, no x, so this is just going to be an x squared down here. And same thing, 2 times 4, 8x, no x, so we put an x in there. All right, then 2 times negative 1 is negative 2. Now we got to add our 6 boxes together, right? So just write out the big addition, right? Each of the 6 boxes, just write them out. 12x to the third minus 12x squared plus 3x minus 8x squared plus 8x minus 2. All right, so I got all 6 of my boxes written out over here in a big long addition and subtraction string, and then I'm just going to look for things that I can combine, right? So anything that's got the same variable and the same power can be combined, right? So for instance, negative 12x squared and negative 8x squared, those can be combined. Positive 3x and positive 8x, those can be combined. Okay, so I'm going to go back to my pen here and I'm going to rewrite it with those things combined. The 12x to the third didn't combine with anything, so it's just going to be carried down. And then negative 12 and negative 8 combine to give me a negative 20x squared. Okay, so those have been combined. I got the 12x third down there, so I'm going to take care of this one next. I got a positive 3x and a positive 8x. Those are going to combine to give me a positive 11x. So those have been taken care of, and all that's left is minus 2. There's my final expression. Okay, so this is equivalent to this. It's just written in a different way using multiplication. All right, again, another way that we can write equivalent expressions is by using factoring techniques. Okay, so we've been talking a lot about factoring throughout the semester. So I want to take this expression and I want to write it in its factored form. That means I'm going to write it in a way that looks like this, right? Where we have the two parentheses, and these two things, they will be equivalent. But to get there, I have to use my box and diamond. Okay, so here we go. So we always use a 2x2 box for this. It always works out to be a 2x2 box. I always use a diamond to kind of help me organize my numbers. All right, and then we take this first term, 2x squared, goes in the upper left-hand box. The last term, the negative 5, goes down here in the bottom right. And then this negative 9x goes in the bottom of my diamond. Okay. To get the top of my diamond, I need to multiply this diagonal here. So I'm going to take 2x squared times negative 5, which is negative 10x squared. And then to figure out what goes here in this diagonal, I need to find two numbers that multiply to negative 10, but add to give me a negative 9. Okay. And those two numbers are going to be negative 10x and positive x, right? A positive 1x. All right, so let's test it out. Negative 10 times 1 is negative 10. Negative 10 plus 1 is negative 9. So these are my two numbers. I'm going to put those in my diagonal. There we go. And then we start working on the sides. All right, so to get a 2x squared, we know we're going to need a 2x and an x. And the way I like to think about this, I like to go ahead and put my x and my x in there, right? Because the x times x gets me the x squared. But I need a 2 to either go here or here. And I'm going to put it here because 2 goes into 2 and 10 nicely. Okay. If I had put the 2 up here, the 2 would go into the 2, but not the 1. All right, so that's how I made that decision. So now I'm thinking, well, x times something makes 1x, right? So that's got to be a 1. And then 2x times something that would go here makes a negative 10. Well, that's got to be a negative 5. Okay, and now we can see our factors here on the sides. So this is going to be 2x plus 1, and this is going to be x minus 5. There is my factored form, which is equivalent to its original form here. So these are equivalent expressions obtained using factoring. All right, guys, that's it for today. Have a great day. Give the practice problems a try. Make sure you text me any questions or shout out in the Zoom chat if you have any questions. Have a great day.